All right, so I'm live with 52 weeks of Swift, and I'm going to talk about concurrency right now and dive into some of the details involving concurrency with the Swift language. And the best place to start would be to share my screen. So I'm going to go ahead and do that. And let's talk about this in a nutshell. Let's see here. All right, so to get started, first I'll talk a little bit about concurrency. One of my favorite things to do in programming is to deal with concurrency, and a few reasons why I think concurrency is fun is that it's hard, right? So that's one of the cool things about it. But also there are ways to use different techniques to make it less hard. And in particular, async is one of the things that can be both helpful but complicated, because anytime something's running asynchronously, it is non-deterministic, right? You don't know when it's going to finish its task. Also, with things like parallel code, you sometimes do want to have some form of a control over the parallel code, let's say like a queue, right? Where you have workers and they're working on a queue, so that you don't have just wild, out of control concurrency. And so there's really a series of trade-offs that you need to make when you're dealing with concurrency. And there is a lot of really awesome code that's available in the Cocoa framework that I've used in Objective-C that was very helpful to me. In this case, though, I'm going to explore the Swift language, which I know less about. I'm going to dive into some of these concepts. So potentially the first thing that I can do here is just make this larger. So make this maybe a full screen here, and we can kind of dive into the Swift language here. And so if I wanted to build something that was non-library centric, you could build something like this. According to the documentation, I would, let's say, take some photos and I would download the photos. But what are the problems with this is that this can be really complicated to figure out. But instead, one of the things that you can do is you could use more of this style, right? Where what you would do is you would say, build a function and say, here's some asynchronous networking code. And once that code has been defined as async here, we're able to actually have it do it in a much more readable way. And that's what these async libraries do, is they make code that is more readable. And so if we wanted to build something that fetches the names of all the pictures in a gallery, how would we do this? Well, we could go ahead and take this. We could say, let photo names await. So basically, go here, fetch all these things, and then go ahead and grab the results of those, sort them, and then finally go through here and download all of those photos. So basically, the list photos here and the download photo both need to make the network requests. And so this is going to make things more complicated. And so as a result, what we have to do is make those async. And so the rest of the code can keep running, and they can wait for the results of that and then process the rest of it. And so in a nutshell, what does this mean? It means that the code would start running from the first line and runs up to the first await. And it calls the list photo in gallery function and suspends execution while it waits for that function to return. And then while this code's execution is suspended, some other concurrent tasks in the same program run. So in the example here, there could be a long-running background task that continues to update a list of the new photo galleries. And this code can also run until the next suspension point, which is the await. After the list photos in this example is able to run and return, this code would continue in execution at the starting point, and it assigns the value, was returned the photo names. So really, it's a way to kind of elegantly build something that is non-deterministic in nature, but looks procedural when you're going through and you're building this. And so this is a nice style here. And so if we wanted to as well build out another kind of example where we had code in between of the suspension points, we could do something like this, like let photo await, go ahead and add this. And then at this point, the first photo is temporarily in both galleries. And there's no way to run the code between the call to add gallery and remove gallery. During that time, the first photo appears in both galleries, breaking the app into one of the app's invariants. And to make it even clearer, the chunk of code must not have a wait, and you can refactor it into a synchronous function. And how would that synchronous function look like? If we went through here, it would look something like that, right? Here's a move, go through here, add the photo, remove the photo, let first photo await, and then go ahead and move it. So what about sequences? Well, one of the things you can do as well is you can return the whole array at once after the array's elements are ready. Another approach is to wait for one element at a time and then iterate over the async sequence. And so this is kind of a cool style as well that I like. So you say import foundation, let handle file handle dot standard input, try to await line in handles dot byte lines, and print line. And so basically, instead of doing a for loop, which in the case of a huge data structure, it would potentially cause massive disk IO issues, is that this would actually wait for each iteration. And so it means that you can build things on top of this. So you could build like a pipeline type operation. Now, you also could build asynchronous functions in parallel. And so you could call async functions with a wait, running only one piece of code at a time. So while the async code is running, the caller waits for the code to finish and fetches the first 3 photos from a gallery. So if we go through here, we can go ahead and do this. So let first photo finish, second photo, third photo, and then at the very end, go ahead and do this. And so the drawback, though, is that the download is asynchronous, but only one call to download photo runs at a time. So each photo download has to complete before the next one. But if I wanted to run the async function in parallel and let it run with code around it, you could write an async in front and then await each time you use the constant. So this would be like a faster version of that. Instead of that, that's the slow, because there's some blocks here. So this is slower, and full async would be here. Full async, which would be async let, would be in front here. And so in this case, we don't have to wait for one of the calls to complete. Each one of these is completely independent and able to do, like, let's say one of these takes a really long time. It's not going to hold up the other one in this particular example. And so the difference is that you have to call async functions with a wait when the code on the following line depends on the function results. This creates work that is carried out sequentially. If you call async functions with async let when you don't need the results until later, this creates work that can be carried out in parallel. And so you can use both await and async let. So pretty cool stuff. Now, this is something I've used, I believe, more in Objective-C, and I think it's probably using something similar, but you use this concept of a task or a unit of work, which I actually like a lot better as a style of concurrency instead of building a bunch of like manual concurrency methods here. And so in this case, I would say await with task group. You go ahead and you do some work here, and then you would actually add that to a group. And one of the neat things about this is that you could basically treat some concurrency task as basically a group of work that you're going to do, and you can just run that off somewhere. Now, with unstructured concurrency, this would be basically you don't have a parent task and you have the flexibility to manage things on your own. And so if I was going to go ahead and do that, for example, I could go ahead and do something like this. So this would be non-task group style here. We say return await handle. If you want to cancel a task, you can do that as well. And then there's also actors. And so an actor you can use to break up the program into isolated concurrent pieces. And each of these are isolated from each other, and they let you share information between the concurrent code. Like classes, actors are reference types. And so the comparison applies to actors as well as classes. Unlike classes, the actors allow only one task to access their immutable state at a time, which makes it safe for code in multiple tasks to interact with the same instance of an actor. So here we go here. This is definitely a fancier version of concurrency. And so I guess the idea here, let's add an A here, would be that this allows you to not have to worry about something that's massively parallel being mutated, in ways that you don't expect, is that it can only be mutated with one interaction at a time. And so with an actor keyword, you can actually go through here and create an instance of an actor using the same initializer syntax as well. And then also the other thing you can do is code that's part of an actor doesn't write a wait. For example, you can actually just use a method to update it. And there's also sendable types. So tasks and actors let you divide a piece into pieces, and you can run that concurrently as well, which is pretty interesting. So some types are sendable, like structures that only have sendable properties. And here's an example of what that would look like. Okay, let's go ahead and do this. So we have struct, there we go, extension, add reading. We have let logger, let reading. And in this case, I believe we're adding the reading here, which is a function from reading. And so in this particular example, what we're doing is we're using the sendable protocol. I guess the sendable protocol is a type whose values can be safely passed across concurrency domains by copying. I guess it would be that because you're copying, you don't have to worry about it being mutated. So there's some really fancy stuff that you can do with concurrency. Some of it feels like what I've done in other languages like Erlang, and I definitely am excited to play around with this a little bit more. But that's all I got for today, and I will see you next week. And I'll talk a little bit more about Swift. I think next week I'm going to cover typecasting. All right, see you next week.